This is Unit 7 Circles, Preview Video 7.3, Part 2. Taking a look here, don't forget your date, time, and location. We're going to go ahead and summarize our 7 angles. So we have here, from the top, very quickly, because you need these equations. Measure of a central angle to its arc, the same. The smaller angle of inscribed is half the arc, its plane. A tan-chord angle is the same as the one inscribed. A chord angle is half the sum of the arcs it strides. Secant, secant, tangent, secant, tangent, tan angles are all the difference of the arcs multiplied by half. Sing it one time through. Sing with me with absolute uninhibited gusto. Let's see if we can't scare both the parents and the pets with your amazing singing abilities. Measure of a central angle to its arc the same. The smaller angle of inscribed is half the arc its plane. A tan-chord angle is the same as the one inscribed. A chord angle's half the sum of the arc it strides. Secant, secant, tangent, tan angles are all the difference of their arcs multiplied by half. Now we're going to be able to do some problems using algebra. Step 1 is you want to identify what kind of angle we're working with here. So this is a secant, secant. Step 2 is you want to write the equation that works with this, and this is angle equals big arc minus little arc over 2. Now, very carefully, we circle, plug, chug. When we identify our angle here is 54. So we have 54 is our angle, equals. Our big arc is this whole thing, so that's going to be 17x plus 14 minus, now here's the tricky part, we're minusing this arc right here. So make sure this is, what I'm about to do is make a mistake, so watch carefully. If all you do is do 5x plus 2, that's going to be a mistake, because in this scenario, you're only subtracting the 5x. But this angle here is, the arc is that entire entity, 5x plus 2. So make sure you keep parentheses around that entity, which is the arc, over 2. Now we're going to cross multiply to solve for x. And I am getting on here, I'm going to have 17x plus 14. And very carefully, I'm going to distribute. That's negative 5x minus 2. And then that's 54 times 2. So come over here. We're going to collect like terms. So 17x minus 5x, that's going to be 12x. 14 minus 2, that's positive 12 equals, and this is going to be 108. So here we have a 6 and a 96. And I want to figure out what 12 goes into 96. So I'm going to just divide by 12. And without using a calculator, first I'm just going to divide each by 2 and get it down to a smaller number that I'm comfortable with. So that's 6. And 46 divided by 2, so that's 48. And now it's a little bit easier to see how that works. 6 goes in there 8 times. So my x is 8. So now you come over here, and we're going to see how this works. And we're going to make sure it does work. So 17 times 8. It's going to be 136 plus 14. So we get here that this arc is 150. Coming down here, 5 times 8 is 40 plus 2, so that's going to be 42. And then we see if it actually works. So we do 150 minus 42 and we get 8. It's 108, and of course we're dividing by 2, and lo and behold, ta-da, it is 54. So once again, the algebra, you identify the type of angle, and then you're going to write the equation very carefully, and then we do the algebra. This one is angle equals arc. This is a chord, so it's arc plus arc over 2. Circle, plug, chug. Our angle here is going to go on this side, so we have 11x minus 5 equals, our big arc is 8x plus 8. Small arc, 12x minus 4 over 2. Cross multiply. So that 2 times 11, that's 22x minus 10. Over here, I'm going to collect like terms. That's 8x plus 12x. So that's going to make 20x. And then I have 8 minus 4, so that, of course, is positive 4. Solve for x. End up with 2x equals 14 and x equals 7. Now, just because it's a whole number doesn't mean you're correct. You have to go back and actually check the work and see if you're correct. So 11 times 7, 77, minus 5, that's going to give us 72 here. So we got to see if this works. 8 times 7 is 56. So that gets us 64 here, and then coming over here to the blue, that's going to be 12 times 7. It's 84 minus 4 is 80. So now we check. 64 plus 80 is 144 divided by 2, and there's your 72. You know you're correct. That's your check. So that's one type of thing, is using algebra and the equations to solve. Another type you have to be able to be comfortable with is these multiple angle problems. Multiple angle problems. So your first order of business is to simply properly label what we have here. We are told, we're going to do this one on paper because it's easier to work with, is we're told that the measure of angle 6 is 40. So that is angle 6 is right here, that's 40 degrees. Measure of angle 4 is 60. And the measure of angle 15 is 50. Now, our goal is to find everything possible. So we're going to start with our ons. So we just darken all our ons. And that's where we're going to start focusing on first. So step 1, I am going to frame my first on that I labeled, which was actually angle 6. So I frame that up. That's a tan chord. Tan chord is the angle's half the arc, so that means this arc right here is going to be 80. Keep that in mind. Okay, now I'm going to walk around what I have. I did angle 4. Angle 4 is an on. So if this is 60 back here, that makes this right here 120. I'm going to frame the 50 up. If this is 50, this out here is 100. And you always want to go arcs before angles, if at all possible. So I go around this way, and you see I have 80 plus 120 is 200. That's 300, which means this right here must therefore be 60. Now you just keep framing and finding everything possible. So I'm going to start at 4, and I'm just going to start working my way around. Since I have all the arcs, I can now get all the inscribed angles. So I'm going to frame at 5. That's an inscribed angle. Sweep the angle. Sweep the arc. That's inscribed. That means that is 60 degrees. I'm going to move clockwise. I already got the 15, so I'm going to move here to angle 14. My arc is 80. That means my angle's 40. So here, 13, sweep with your finger, sweep that. That's 30, of course, because it's inscribed. And I'm just following around the clock here, following around the clock. This angle 1 is grabbing the 120, so that makes that 60. This is 80 here. Back here, that's 40. So look at all this information. Angle 3. Angle 3 is grabbing the 100, so angle 3 is 50. Then you check. It's like, okay, now I have all my inscribed angles. Now I'm going to start looking for other angles. So it's a little bit harder to see these other angles. So I'm going to color them for you. This is a chord. And remember, a chord is arc plus arc over 2. So this and this angle, 10 and 12, is going to be, that angle is going to be arc plus arc over 2. That angle is, one arc is 60 that we're grabbing. The other arc is 120 over 2. That makes this 60 plus 120 is 180 over 2. That makes this angle right here 90 and 90, which forces, of course, angle 11 and 9 to be 90. But wait, there's more. You look and you're like, I've got all the angles, but there's lonely angle 8 way out here. And this is a secant tangent. And it's going to equal big arc minus little arc over 2. So this angle right here is this big arc minus little arc over 2. So angle 8 is big arc minus little arc over 2. Angle 8. You reach out here, and our big arc here is 120. Our little arc, that's 80 over 2. And it's 40 over 2, which makes angle 8 20. Look at all that information you get just using the different angles. So on that note, friends, I want you to attempt to do this page on your own. Let me just clarify what you have here. That's 80. That arc right there is 60. This angle right here is 40. That's 90. At this point, I'd like you to pause the video and attempt to do all the angles that you can, and then restart the video. Pause. Okay, students, let's see how you did. Measure of a central angle to its arc the same. So if this is 90, that forces this out to be 90. And since this is a 90-degree wedge, and I tell you that's a diameter, that means this is 90, and this arc out here must also therefore be 90. That's 60 there if you were to frame up this inscribed angle. That's 60. That makes this 30 going this way. And you're like, well, what else can I find? Watch very carefully here, folks. You want to ask yourself what else you can find. If this is 60, that means this entire thing right here, the entire thing right here is 120. And you're like, I'm stuck. Now what? Don't overlook the obvious, folks. This right here is a triangle. 40 and 80 is 120. Take away, and that means this right here is 60. And that means we are framing this up. And if this is 60, you reach out from here. Okay, this arc right here, I'm going to squiggle it in black all the way. Has to be 120. Has to be 120. Which means if you color code it, and that black arc is 120, and the blue from here to here is 60, means this purple crosshatch must be 60. Which would make blue squiggle from here to here also 60. It's not drawn to scale. You get close here. If that's 90, then from here to here must also be 90, which makes this 30. And if we come back here, we know that's 60 there. And you just keep asking yourself, what else can you find? So here we have that 40, and we have this 60. So here's the key to the whole problem. I'm running out of colors. What have I not used? I've not used this red here. Ready? That's a chord, and it is angle equals arc plus arc over 2. And our angle is 40, and our one arc is 60, and then our other arc, which is this little guy, which you don't know, in red, we'll call that x over 2. Cross multiply, I end up with 80 equals 60 plus x, and x equals 20, which means this little piece is 20, which come back here, that makes this 10, and this 20, which makes this dotted arc 40. So much information. It's like a giant puzzle. Very few of you got all of those. If you did get all of them, give yourself a giant, huge, smiley star. Woohoo! Woo-hoo! You certainly deserve it. Those of you who missed something, which the vast majority of you most likely did, I expect a little note. What are you going to remember next time?